This is part 2 of our video on operations with logarithmic functions. So we're going to be looking at question number 2 that says, use log rules to write each of the following as like terms if possible. And then we have 3 different pairs of what are currently unlike terms, and we're going to try to see if we can find a way to make them like terms. Now, in order to do that, we are supposed to use log rules. I do not have my green sheet with me, but I do know my log rules, so I did write them down. So on the very last page of your green sheet, we have 4 log rules. There's the one that says when we add 2 logs with the same base, we can combine them into one single log by multiplying their arguments. We have one rule that says when you have 2 logs with the same base that are being, oh, that should be a subtraction, not a division sign. When we are subtracting 2 logs with the same base, we can combine them into one log by dividing their arguments. We have one rule that says when you have an argument on your entire, an exponent on your entire argument, you can bring that exponent down out front and multiply. And then the last rule is our change of base rule that says if you want to change the base to something else, you can do that as long as you do log of that new base of the argument divided by log of the new base of your old base. All right, so we're going to use those to help us see if we can find a way to write these as like terms. So up first, I have log base 11 of x cubed and log base 11 of x to the 5. So when I look at this, I want to first identify what about them makes them not like terms. They have the same base, but right now what they have are different arguments. So I want to see, is there a way for me to do something to change it so that they have the same argument? So I'm going to take a look at my log rules and see if I have anything here that might help me. Right? We currently have x to the 3 and x to the 5. So I'm going to look to see if I have a rule where I have an argument with an exponent on it. And I have one right here that says log base b of x to the power of n is the same as n times log base b of x. So we can take that exponent and bring it down in front and multiply. So I'm going to try that with each of these terms. So log base 11 of x cubed, I'm going to bring the power of 3 down in front and say this is 3 times log base 11 of x. Okay, let's try the other one. We have log base 11 of x to the 5. We're going to try the same rule. We're going to bring that exponent down in front. So this is 5 times log base 11 of x. Are they now like terms? Well, they have the same base, they now have the same argument, and there is no exponent between that log and the argument, so we're good. They have different coefficients, but that's okay. So I'm going to say, yes, they are like terms. I know that's not what the question actually asked. It just said write them as like terms if possible, but I do want to indicate that they are actually like terms. All right, our second one, we have log base 2 of 8x and log base 2 of 4x. And I want to see if I can find a way to write them as like terms. So I'm first going to try to see what it is about them that's not currently making them like terms. So I do see they have the same base, but once again, they have different arguments. So I want to try to see if I can find a way to take those arguments and write my logs in a different way. So I'm going to go back to those log rules. They're on your last page of your green sheet. We're going to try to see if we can find anything here that would help us. Now the rule we used in part A isn't really going to help us here because I don't have an exponent, right? Instead, we're multiplying 8 in x and 4 in x. So I think the rule that probably would be most useful is the first one, because we have a log and we have 2 things being multiplied. Here I have 8 times x, here I have 4 times x. So we're going to try using this log rule backwards to split it up into the addition of two logs. So in this case, the x for us is going to be 8, and the y for us is going to be the x. So log base 2 of 8x would be the same thing as log base 2 of 8 and then plus log base 2 of x. Now, I can't do anything with log base 2 of x because it's a variable, but I think I can do something with log base 2 of 8. Now, I don't have my power sheet with me, and you should on your green package, but I know that 8 is 2 to the power of 3. So this is log base 2 of 2 to the power of 3. And then plus log base 2 of x, which means this first log just equals 3 plus log base 2 of x. All right, we're going to try something similar with the second one. We're going to take log base 2 of 4x. And very similar to this one, I'm going to use that multiplication rule here to split it back up into addition. So I would do log base 2 of 4 plus log base 2 of x. So log base 2 of 4 plus log base 2 of x. Log base 2 of x I can't really do much with, but the log base 2 of 4, I know that 4 is 2 squared. So this is log base 2 of 2 squared plus log base 2 of x. So log base 2 of 2 squared is just that exponent of 2 plus log base 2 of x. Okay. So I don't just have one term. I now have two terms on both sides. And the question is, are they like terms? So parts of them are like terms. The 3 and the 2 are like terms. They're both numbers. And the log base 2 of x and the log base 2 of x are also like terms because they have the same base, the same argument, and I don't have an exponent there, but they would have the same exponent. So I am going to say that these are actually like terms, right? Except now we've got different parts to the like terms, but they are still like terms. So I'm going to say, yes, there are like terms. So yes, there are like terms. All right, we have one more to go. That's our very last one. We have log base 9 of x squared and log base 9 squared of x. So in terms of being like terms, right now they have the same base. They have different arguments. This one is x, this one is x squared. And they do have different exponents. This one has a square in between the log and the x. This one does not have a square between the log and the x. The square is on the argument. So if I take a look at any rules that I might have, the only thing that I could think to use would be that third one, right, with the exponent that we used in the first question, where I could bring that exponent that's on the argument down in front. So I could take log base 9 of x squared, and I can use that rule to write that as 2 times log base 9 of x. Now the other one, the exponent is not on the argument. The exponent is actually on the log. So log base 9 of x squared really means log base 9 of x, and then that whole thing is multiplied by itself, it's squared. So unfortunately, I cannot bring that 2 down to the front, right? Because this rule only works if the exponent is on the argument. It does not work if the exponent is on the log. So because this does not have an exponent between the log and the x, and this one does, and there's no alternative way for me to write this, unfortunately, these are not like terms. And I'm just going to make a little note that they have different exponents. All right, so we managed to write the first two as like terms, and then that last one didn't work out because they had different exponents and I just couldn't do anything about it. All right, I will see you in the next video to take a look at the next part of the note.